Hello, everyone. So I want to finish up our conversation about meiosis by talking about Edwards syndrome, by coming back to that. So we have introduced this in one of the videos. It's a serious condition that basically affects newborn babies immediately with multiple organ system problems, and there are extreme health issues. So rarely, if ever, do they live maybe for a few months of age, just invariably fatal at a young age. So something that we hinted at, and we can detect it before birth with testing, screening testing. And part of the reason we know who to screen is it's more common in women who are older when they're pregnant. So like I was saying, 40 or 45-year-old woman is far more likely to have a baby with Edwards syndrome than a 20-year-old or 18-year-old mother. So it's something that seems to increase with the age of the mother. So we know how to screen for it. So I want to talk about a little bit what it is and how that happens. So now that we talked about meiosis, what causes Edwards syndrome is something called non-disjunction of chromosome number 18 during meiosis. The term non-disjunction means the chromosomes don't separate normally. So what ends up happening is that a baby, it accidentally inherits an extra copy of chromosome number 18. So it's like instead of getting one from the mom and one from dad, somehow it got two from mom and one from dad, or one from mom and two from dad. It doesn't really matter significantly whether extra copy comes from mom or from dad, but whatever happens, there is an extra copy of chromosome number 18, and it turns out it's a big deal. We're going to talk about this with the chromosomes later in the semester, how it's very important to have exact number of the chromosomes and how it can cause health issues if there's an extra copy or there's one missing copy. So so it's really important to have chromosomes in balance in our bodies. So we're made to have everything in perfect balance, 2 copies of every chromosome. Anytime there's an extra chromosome, there's a risk of something bad can happen. And for most chromosomes of our body, it's actually a very severe risk. This it's not one of those mild conditions or mild things that can happen. It's very serious. So this is also known as trisomy 18. This is also known as trisomy 18. The word tri means 3. Somy is referring to chromosomes. So basically it just means somebody has 3 chromosomes of number 18. How does that happen? So here's an example of non-disjunction. So how that could happen is, if you remember in meiosis, what's supposed to happen is what happened with these little chromosomes here. So that's 2 homologous pairs are pairing up with each other. So during meiosis 1, during meiosis 1, the homologous pairs just completely separate to opposite cells, the way this little blue one and this dark blue one have separated correctly. So that's what's supposed to happen. But in this case, what happened is 2 larger chromosomes didn't go to the opposite ends. And they didn't go to opposite directions. They both went to the same side. So in the end result, the gametes, remember gametes are sex cells, so that can be egg and the sperm. The gametes, so this was supposed to have 2 chromosomes here in the end. This one also was supposed to have 2. And it has 1 extra, and these ones are missing 1. So so they ended up with 3. So this was supposed to have 2 chromosomes, and these just ended up with 1. So in humans, these numbers would have a little bit different, of course, because we have 23 chromosomes for haploid number. So if it had an extra chromosome, then we're talking about here having maybe 24 chromosomes, and these are missing ones. So instead of 23, there are 22 here. So instead of 23, also 22 here. That's extra copy here for these 2, and then there's 1 missing copy for these 2. Here's an example of how that can happen. So what that looks like. So on a karyotype is when we look at all the chromosomes of an individual, and then we can see the particular individual chromosome So 1 looks fine, 2 looks fine, and as you're going through, most of them look fine until you get down to number 18, which is right here. And if you look at number 18, there is 3 of them. So this person has trisomy 18 and looks like they're chromosomally female because there are 2 X chromosomes. So everything else looks perfect, but that number 18 is, it has 3 chromosomes that leads to Edwards syndrome. So since that's invariably fatal at a very young age, a lot of times parents want to know about this while they still have an opportunity to terminate the pregnancy. So if that's what they decide to do or they want to do, then they can decide to basically terminate the pregnancy. And we will go over a little bit more detail later, but the way, sorry, I don't know what happened there. But the way this is written, it's written as 47, comma, plus 18. 47 for the total number of chromosomes because it should have 46, but this person has 47 plus 18 tells you which one which one has the extra copy. So we'll talk a little bit more about it later time. We'll come back to talk about chromosomes, but that's the reason this happened. There was a problem during meiosis. So something happened in meiosis where 1 chromosome went the wrong way, and that ended up getting into the baby. And the baby ended up with a copy of 3 sets of this number 18. You can't tell if it's from mom or if it's from dad, but you know that there's an extra copy. You can't tell where the extra copy came from, but there's basically one of the parents did give an extra copy. So I'm going to stop here, and then I'll talk to you about something different in the next video.